Helicopters are remarkable machines. Their ability to take off and land vertically is unique. They can hover in place, a feat fixed-wing aircraft cannot achieve. This versatility allows them to operate in diverse environments. From cityscapes to rugged terrain, helicopters perform critical tasks. They are indispensable for medical services, law enforcement, and agriculture. Their agility makes them seem limitless. But this freedom comes with inherent challenges. Despite their capabilities, helicopters face significant threats. Power lines are a persistent danger. These cables often traverse low-altitude airspace. For pilots, these wires are lethal obstacles. They are difficult to detect, especially in bad weather. Wire strikes often lead to catastrophic accidents. This guide is crucial for pilots. We will explore why these structures are hazardous. Understanding these dangers is key to preventing accidents. The primary danger of power lines stems from their inherent lack of visibility. These wires are often surprisingly thin, especially when viewed from a distance, or against a cluttered background. A pilot scanning the horizon might easily miss a solitary wire, or even a series of them if they blend seamlessly with trees, terrain, or buildings. This phenomenon, known as visual clutter, makes the power lines appear to vanish into their surroundings. Lighting conditions play a significant role in exacerbating visibility issues. Bright sunlight can create intense glare off the cockpit windscreen or the wires themselves, temporarily blinding the pilot. Conversely, during dawn or dusk, the low angle of the sun can cast long shadows or create flat light conditions where depth perception is compromised. Overcast days with their diffused light can also reduce contrast, causing power lines to fade into a gray sky or a muted landscape. Weather phenomena further complicate the task of spotting power lines. Conditions such as fog, mist, rain, or snow directly reduce visibility, sometimes dramatically. Many helicopter missions require low-altitude operation. Agricultural spraying, pipeline patrol, search and rescue, and EMS often involve flying just above the ground. Power lines are prevalent in this low-altitude environment. New lines appear or old ones are rerouted with little notice. This increases the probability of an encounter demanding high situational awareness. Power lines present a severe electrocution hazard. Striking a live line can incapacitate the crew or ignite fuel. A damaged aircraft in live wires poses extreme rescue risks. Transmission lines carry instantly lethal energy. A wire strike often results in rapid loss of control. Avoiding the strike is the only reliable safety measure. Section 4. Fortifying the cockpit, pre-flight diligence, and protective systems. Thorough pre-flight planning is the first line of defense against power line hazards. Pilots must meticulously study their intended route, consulting aeronautical charts, databases of known obstacles, and even satellite imagery if available. Special attention should be paid to areas where power lines are common, such as near substations, across valleys, or along roadways and railway lines. For low-level routes, pilots should actively seek out information on recently constructed lines that may not yet appear on official charts. Identifying known wire locations is crucial, but pilots must also anticipate the presence of unmapped or temporary lines, especially in remote or rapidly developing areas. Many helicopters are equipped with a wire strike protection system, or WSPS. This passive system typically consists of a series of sharp blades mounted on the upper and lower fuselage, designed to cut wires that the helicopter might inadvertently strike. While WSPS can be life-saving, it is not a guarantee. It is essential for pilots to understand the capabilities and limitations of their aircraft's WSPS. Section 5. Seeing the unseen. Advanced technology and pilot proficiency. Enhanced vision systems, or EVS, and synthetic vision systems, or SVS, are becoming increasingly valuable tools in mitigating wire strike risks. EVS typically uses infrared cameras to provide pilots with an image of the outside world, which can help detect wires, especially at night or in poor visibility. SVS creates a computer-generated depiction of the terrain and known obstacles, including some charted power lines on the pilot's display. Visual markers on power lines, such as large, brightly colored balls or specialized lighting systems, greatly improve their detectability. Comprehensive pilot training is fundamental to avoiding wire strikes. This training must go beyond basic flight maneuvers and include specific modules on wire detection techniques, risk assessment, and emergency procedures for inadvertent encounters. Simulator training can be particularly effective, allowing pilots to experience and react to wire strike scenarios in a safe, controlled environment. Recurrent training helps keep these skills sharp and reinforces the importance of vigilance. Ultimately, technology and regulations are aids, but the pilot's skill, judgment, and unwavering commitment to safety are the most critical elements in preventing powerline accidents. Section 6. Tragic Lessons, Case Studies in Wire Strike Accidents. The 2024 Valencia crash serves as a stark reminder of the ever-present danger of power lines, even in areas where flight operations are common. In this incident, a firefighting helicopter operating at low altitude to combat a wildfire reportedly struck an unmarked power line spanning a small valley. The terrain was challenging, and visibility was likely compromised by smoke and the urgency of the mission. The helicopter, heavily laden with water, lost control almost immediately upon impact and crashed, resulting in fatalities. This accident highlighted the increased risks faced during emergency operations, where mission focus can sometimes inadvertently overshadow obstacle awareness. Another significant incident occurred in North Carolina in March 2009. A Duke Life Flight medical helicopter crashed after striking a nearly invisible steel cable associated with a radio tower guy wire system while en route to pick up a patient. The accident happened at night but in clear weather conditions. The crew was highly experienced. These real-world examples teach hard lessons that vigilance must be constant, planning meticulous, and reliance on any single safety measure insufficient. Section 7 Conclusion. Cultivating a culture of unwavering safety. The inherent dangers posed by power lines to helicopter operations cannot be overstated. These structures, essential to modern life, represent a persistent and often invisible threat in the low-altitude environment where helicopters excel. The risk of a wire strike, with its potentially catastrophic consequences, demands unwavering attention from every pilot and operator. Essential safety precautions, ranging from meticulous pre-flight planning to the use of advanced technological aids, are critical components in the defense against wire strikes. Systems like WSPS offer a last line of defense, while enhanced vision systems aim to make the unseen visible. However, technology alone is not a panacea. The ultimate responsibility rests with the pilot to integrate all available information, maintain situational awareness, and adhere strictly to established flight guidelines and best practices. Preparedness, a deep understanding of the risks, and an unwavering adherence to best practices are not just recommended, they are imperative. By cultivating such a profound culture of safety, the helicopter industry can continue to harness the unique capabilities of these versatile aircraft while diligently mitigating one of its most significant operational dangers.